Hello, everyone. Am I audible?
Hello. Good evening, ma'am. Yes, ma'am, you are audible.
Yeah, good evening. So there are only four members here. So did you not get any reminders or anything?
No, ma'am.
You didn't get for today's class? No reminders?
No, ma'am.
Is it for every class or like for today only?
Uh, Ma'am, in fact, I have seen only emails and I didn't receive any email regarding this.
Okay.
Yes,
Okay, let's wait for a few more minutes and then we will start the session. Fine?
yes, ma'am. Okay.
Okay, students. So shall we start?
Yes, ma'am.
Yeah. So I need answers from everyone who all are there. So we can
Yes, ma'am.
yeah. Okay. So in total, how many students are there? There are only 7 students, right? They're joining right now. Okay. Okay, fine. So has anyone seen or watched week 4 content?
Yes, ma'am.
Every
Yes, ma'am.
everyone?
Yes,
Okay.
ma'am.
So okay. So
Yes,
week 4
ma'am.
is all about association, right?
Yes,
Are
ma'am.
you to see my screen?
Yes.
Okay, fine. So, okay, before that, in association, we have two types of variable, right? So, what are the two types of variable?
Numerical and
And
Categorical and numerical.
sorry,
Ma'am, categorical and numerical.
yeah, we have two types of variable, that is numerical and categorical. Good. Okay. So in association, now in this week, we are going to talk about the association between two categorical variables, one categorical and one numerical variables, and two numerical variables. Okay. Okay, now. So our first thing is, if we have two categorical variables, then how will we associate between them? Okay. Now, let's take an example. We are comparing. Anybody said anything? Okay, so we are comparing between two categorical variables, that is the gender. I'm just taking an example, uh, same as ma'am took, the gender and the use of smartphone. Okay, just ignore my writings. Okay, okay. So when we are calculating the association between two categorical variables, we first make two-way contingency table. Okay, this is our first step. Two-way contingency table, right? Then the second thing is we calculate the relative frequencies. So we have two types of relative frequencies. The first one is the row relative frequency and or column relative frequency. Okay. Okay. So first of all, let's try to make two-way contingency table. Are everyone able to understand?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. Okay. So let's make a two-way contingency table. So I'm having some of the, so what is a contingency table? Can anybody tell me? Anyone?
Ma'am, it's a two variable table that basically creates a sort of representation of how those two variables are related.
Yeah.
Ma'am, it's the representation of data in two ways.
Sorry?
We can interpret the data in two ways.
Yeah. So basically, it is just a summary. Okay. So it is just basically it is a summary of a data. If we have a long kind of data, okay. So if we have to organize it, we use the contingency table. Okay. So I'm making like I have some informations like there are 44 females. Okay. Then there are 56 male. Okay. We are just taking that, we are just comparing the gender versus the users of smartphones. Okay. So in that we have 44 females, we have 56 males, and we see that 76 owned smartphones. Okay. And the 24 did not. Okay. Then we have 34 female who own the smartphone and 42 male, okay, who own the smartphone. Okay, so this is the thing that we have got. Fine, this is the like you can say the summary from the data. So this summary can be organized in a tabular form, which is known as the two-way contingency table. Okay, so in this, the first, like we can say here, we have two variables, right? The first variable is owning a smartphone, and the second variable is the gender. Okay.
Ma'am, is this the first question we have started it?
First question? Which first question?
Like I've just recently joined, so I just asked that.
No, it's not a question. It's like
Okay.
It's a week for revision session. Sorry, open sessions. So I'm just summarizing out the whole week. Okay, it's just a starting. It's just an example, the first example that ma'am taught.
Okay, so it's the first slide in the example. First example in this.
Ma'am,
Yes.
I have some doubts in assignment questions. May I
Okay.
ask in this
No,
session?
let's come to that later on. Okay. Let me just
Oh,
complete this thing.
yes.
Then we will come to that. Okay.
Okay, ma'am.
Okay. So now, so in gender, we have two types of categories. There are female and male. And owning a smartphone, we have two categories. That is whether they're owning it or they're not owning it. Okay. And here we have the total. And this is the column total. Okay. So this is the female who are owning a smartphone. They are 34. Correct. Okay.
Yes, ma'am.
Let's go by the number wise. Okay. So the first thing is we have 44 females, right? So in total, how many females are there? There are 44, right? So here I write like this. Then we have 56 male. Okay. Then there are 76 who own a smartphone. That means like there are 76 people who are having a smartphone. Okay. So in total, like in yes column, we would be writing it 76. Is it fine?
Yes,
Okay. And then
ma'am.
in no, here it would be
24.
24. Correct. Now we have 34 female who are owning a smartphone and 42 male who are owning a smartphone, right? So what are the number of female who are not owning a smartphone?
10.
10,
10. And males who are not owning it?
14.
14.
14. So
14.
this is a two-way contingency table which is summarizing our data, okay, in an organized manner. Okay. Now is it like a little bit clear to you understand? It is understandable, right? You get my point?
Yes, ma'am.
Yes,
Yes,
Okay.
ma'am.
ma'am.
Okay, fine. So everybody understood what is a contingency table?
Yes, ma'am.
Okay, fine.
So, ma'am,
Okay.
in a contingency table, we have two variables left and right, like
Yeah. So
yes and
see,
no, and like that.
yeah. So we have two categorical variables, right? So we are comparing the gender versus owning a smartphone. So these are two categories, the variables. Actually, this is a variable 1 and this is variable 2. Okay. And in this variable, this is a nominal type, right? So we have female and male. So this variable 2 is also a nominal type. So we have two types, yes or no. Okay.
Yes, ma'am.
Male and
Okay,
female is
ma'am.
nominal.
Sorry.
Male, like yes and no is nominal here, nominal variable,
Yes. Yeah.
and male and female is also nominal here.
Nominal. Correct.
Both are nominal.
Both are nominal.
And this is called contingency table, I guess.
Yeah. This is a contingency, two-way contingency table. Fine.
Ma'am, yes and no, it will be numerical variable. Number, it is representing number of smartphone. That's why it should a numerical
No,
variable.
no, no. See, no. See, if I'm having an Excel sheet, okay. So in that I have one common column which is denoting the gender, okay, and one column I'm having you can say owning a smartphone, okay. So like I would be having an Excel sheet in which I would be having some data like female, male, male, female. They're owning a smartphone. They're owning a smartphone like yes, no, no, yes, something like that. So it's not a numerical, it's just nominal. Okay, there are
Yes,
two types.
yes,
Yes
ma'am.
or no, that's it. Fine.
Yes, ma'am.
Okay. So till here, is it clear to everyone?
Yes, ma'am.
Okay.
There can be a categorical variable also.
These are categorical variables.
Okay. No, you said a nominal variable.
See, in yeah, so these nominal variables, like what are nominal variables?
Ma'am, uh, kind of categorical variable it is.
Yeah, actually is.
Hmm.
That's the thing.
Nominal is the type of categorical, and this topic is the association of categorical variable.
Yeah. So yeah. So in like we would be having some data, like let's say if I'm comparing the income, okay, income and owning a smartphone. So in income, I'm having three categories, right? So it can be high income, okay, it can be low, it can be medium, right? So now tell me what type of categorical variable this is.
Ma'am, ordinal.
Ordinal, ma'am.
Yeah. The thing. So in categorical, I'm having a nominal variable. This is my nominal variable, and this is my ordinal variable. Got it? Got the difference?
Yes, ma'am.
Everyone?
Yes, ma'am.
Good. Okay. Okay. So we have made the contingency table. Now, how are we going to associate between the two variables? So for that, we calculate the relative frequency. So can anyone tell me what is the formula for relative frequency? Anyone?
Ma'am,
Number of
frequency upon
observations
total.
by total number of observations.
Yeah, we can say the frequency divided by the total number of frequency. Correct?
Yes, ma'am.
This is the formula. So, okay. So in relative frequency, in this, we calculate there are two types of relative frequencies, the row relative frequency and a column relative frequency. So let's get back to our table now. Okay. So just tell me what proportion of total participant own a smartphone? Okay. So before that, can you tell me what is the total here?
100.
It's 100. Okay, so I want to know like what is the proportion of total participant owning
76%.
sorry
76%.
76 by 100, correct?
Yeah, 76%.
0.76.
Yeah, so I would be calculating it by 76 divided by 100.
Ma'am,
Yes, ma'am.
76%.
Yeah, same. So I'm just I'm not asking you the percentage, I'm asking in proportion. So the proportion would be 76 by 100.
Yes, ma'am.
Yes, ma'am.
Similarly, for the proportion of total participant who are not owning a smartphone, it would be 24 by 100.
Yes, ma'am.
Correct. Now the next question is what proportion of female participant own a smartphone? Can you just wait for a second?
What is the question, ma'am? Last you said.
Yeah, sorry. Okay, so yeah, you were saying?
Yes, ma'am. The question you asked, the last, owning the smartphone is 76% and not owning is 24%. And after that, what you
Yeah,
said?
after that, yeah, the question was what proportion of female participant own a smartphone?
Means you are asking among 100 or 44?
It's 34%.
34 upon 44.
Correct. So here, so the question is the proportion of female participants. So in total, how many female participants are there? 44. Okay.
44.
So from that, how many of them are owning a smartphone? So I would be calculating the frequency is 34
upon
divided by the
44.
total frequency, 44. Got it?
Yes, ma'am.
This is the row relative frequency. Okay. So what is row relative frequency? We are just dividing the each cell frequency in a row by its row total. Okay. So this is the cell frequency of a row, dividing it by its row total.
What
Got
it is
it?
called, ma'am? Row frequency, row divided frequency.
Row relative frequency. Okay, so if I have to calculate the proportion of male participant who are not owning a smartphone, it would be
52 upon 56.
14 upon 56.
14 upon 56.
56.
Now is it clear what is how to calculate a row relative frequency?
Yes, ma'am.
Yes,
Correct?
ma'am.
Like for each cell, I would be calculating it would be 34 by 44, 10 by 44, 42 by 56. I've calculated for each rows. Is it clear? This is row relative frequency. Is it fine?
Yes, ma'am.
Okay. Yes, ma'am. Now in the same table, okay. Now, that was row relative frequency. Now I'm calculating the column relative frequency. Okay, so in column relative frequency, we divide each cell frequency in a column by its column total. Okay, it's the same way like the row relative frequency. Okay, so the question is like what proportion of smartphone owners are female? Okay, that's the question. Should I repeat?
34
It's
34
34 upon
96.
76.
Yeah, it would be 34 upon 76. So this is the proportion of smartphone owners who are females, correct? This is the column. So we are dividing the cell frequency in a column by its column total. Is it fine? Similarly, what proportion of smartphone owners are male? It would be 42 by
76.
10. Okay, so this way I can calculate for each of the cell. So here it would be dividing by 10 divided by
24.
24. This is 14 divided by 24, 44 divided by 100, and 56 divided by 100. So for each column, I have calculated the column relative frequencies. Is it fine? Everybody understood till here?
Yes, ma'am.
Yes, ma'am.
Okay, if I'm going too fast, you can tell me, okay?
Ma'am, row related frequency. Ma'am,
Right?
we did 34 upon 76. That was a column related frequency, na?
34 divided by 76, yes. What is the doubt you're having?
No, ma'am, no doubt. Just asking 34 by 76 is the column related frequency.
Yeah. So just it's clear, right? So if I'm dividing it by 44, it's the row total, right? So it's a row relative frequency. If I'm dividing it by 76, it's the column total. So it is a column relative frequency. Okay. Understood?
Okay, ma'am.
Okay. Your name is Kashi, right?
Yes, ma'am.
Okay, fine. Okay. So everybody understood what is how to calculate a row relative frequency and a column relative frequency?
Yes,
Yes,
ma'am.
ma'am. Everyone? Okay. Now we have calculated it. Now with that, how we going to associate whether there is a difference between the two variables or not? Okay. So just let me make a table here. Okay. So this is female, male, yes, no. Okay. So here I'm writing a row relative frequency in a percentage form. Okay, so it would be 77.27%. This is 75.00%. This is the total. Okay, so this would be 76%. Then this is 22.73%. This is 25%, and this is 20%. Okay, then this is the row total. Okay, which was like 44, 56, and 100. Okay, so we have calculated the row. This is the row relative frequency. Okay, so we have calculated the row relative frequency. So if we see here, okay, So if the row relative frequency, okay, so there is one condition. If the row relative frequency are same for all the rows, okay, then we say that the two variables are not associated with each other. So if you see here, the values here are like the proportion of owning a smartphone is and not owning a smartphone is 76% and 24%. Okay, so for all, like in this row, we can see it is 77 and 77 and 23%, 75% and 25%. Right. So basically, they are like these values are around 76 only, right? And these values are around 24%, right? So like in each row, we can see that it's a little bit same, correct? If you compare it with the total.
Yes, ma'am.
Everybody getting my point? If not,
Yes,
just
ma'am.
everybody got my point, right? So like if you see here, the points like 70, this is 77%, this is 23%, 75% and 25%, 76 and 24%. So the ratio, the proportion between them is like similar, bit similar in all the rows, correct?
Yes, ma'am.
Yeah. So that's why. So this is like, so we can
Not
see that the row.
associated.
Sorry.
So it is not associated.
Yeah. So this is not associated. So there is no association between them. So we can say that the like the gender and owning a smartphone, there is no association between them. Okay. They are not related to each other. Okay. Gender does not describe whether they are owning a smartphone or not. Okay. So if I'm making another table, let's say, here I'm comparing the income level. Okay. So we have high, medium, low. This is the total. Okay. Yes or no. Okay. So I'm just um,
So,
writing
ma'am,
this.
in a column, so basically,
Yeah. Yeah. You can say it. You were saying something?
yes, ma'am, after you complete after that,
No,
I'll
no,
say.
you can say it. Like, is it about this table, right?
Yes, ma'am, it's about the last table.
Yeah, you can say it. Fine. It's fine. Yeah. Tell me. What's the doubt?
Yes, ma'am, I was saying this, the row of female here,
Hmm.
77, 22, and 44. This is the row of female.
Yeah, correct.
Yes, ma'am. And after that, there is a row of male,
Male. Hmm.
75, 25, and 50.
Correct.
So you are saying you are taking the ratio between these two rows, like 77 upon 22 is approximately equal to 75 upon 25.
No, no, I'm not taking. I'm just like comparing it. Okay, so it's a row
Okay.
relative frequency. So I would be like comparing the rows. Okay, so this is
Okay.
like like this total. This 76% is the total, right? Total percentage of students who are owning a smartphone, right?
Yes.
So if so the female count is like you can say typically around this one, right? 76%. Similarly, the male also is around 76%.
Okay.
Correct. Similarly, in not owning a smartphone, the total is 24%. So female and the count, the percentage of female and male count is also a bit around this percentage only, right?
24%. Yeah.
Yeah. So we can say that the row relative frequencies are same. So there is no association between them. Okay. Just like if you look overall, the numbers are bit same for all the rows, correct?
Yeah.
For each
For the
row.
female, male, and the total, the rows, these three rows are almost same.
Yeah, correct. This way you can just like you can observe the things and just say whether they are associated or not.
So they are not associated in a way.
They are not associated because they are same, right?
We have
Similarly,
to only compare through rows, or we can
yeah, we can compare it by
compare
the
through
column also.
columns
Correct.
also.
So in column, we will be having like we will be comparing like this. So this thing should be like they should be equal to this, right? This 56% should be equal to like the count, the percentage should be equal here also. It should be like, this should be like 53 or something if it comes or something like that. So you can calculate the column relative frequency also. So you can compare it with that. Got it?
How we'll compare the column related frequency like?
Okay, so let's say, so if I'm having, this is the same table, right? So
So it's
let's,
almost same. In the Y column there is 77, 75, 76. So it's
no,
in a
in column, no,
I
in
think
column
we have
frequency,
done here row total. That's why we are comparing row wise. If we
row,
have a column total, then we will compare column wise.
column wise. Yeah. So you can calculate in any way, by row relative or by column. Okay, so if you calculate it by the column relative frequency, then you will be comparing with the columns. Okay, if you are calculating by the row relative frequencies, you will be comparing with the rows.
yes,
Okay,
ma'am. For the column, how shall we calculate? How shall we compare for the column?
Let's say,
It's 7
okay,
column.
let's say the numbers are 44.74%. This is 55.26%. This is 41.67%. This is 58.33%. And these are the total row total, right? So the percentage is 44 and 56. Now you tell me whether they are associated or not. Observe it.
Yes, ma'am.
Yeah. So tell me.
They are not associate, ma'am.
Then
Me-
they're not.
There is an association, ma'am, I guess.
There is an association.
Yes, ma'am.
Are you sure? Anyone else?
Yes, ma'am, because there is a difference, I think 10%.
I think they are not
See,
associate. They are not associate.
they are not associated. If you see
Yeah.
44%, this is actually 42 and this is like 43. So it 43, correct? So this is like around 44 only, right? Similarly, this is 55% and this is 58%. And this total was 56%. So it is around 56 only,
Okay, ma'am. Yes, ma'am.
correct?
So the difference is kind of 10.
Yeah, so there is no difference.
Yeah.
Yeah, so they are not associated with each other.
Because
Got it?
55 minus 44 it's around 10 and
No,
58
just
minus
don't,
41.
no, just don't look it like that. Just don't calculate the difference. Just observe it. Like, see, this is like 44, 41, like it's around 44 only, right? If it would have been like 39,
Okay.
if this would be like 50, then there is a difference, right? Like,
Ma'am, you are seeing this column wise or row wise?
this is column.
So I think before you, the ma'am was teaching which saying that if you want to compare column wise, then there should be a column total. Then only we can compare column wise. Here we have a row total, so we have to compare by row wise.
Just a second, just a second. I think I got. Yes.
I think this is associated because we have to compare row wise because this is a row
No,
total.
we are calculating column wise.
So you don't calculate column total. You calculate
Yes,
row
ma'am.
total.
If you calculate column
Just
wise, then you calculate also to column total.
this is the row, this is the column. Okay. Okay, just a second. This is the row, this is the column relative frequency actually. This one is the column relative frequency, not the row relative frequency. This is the row relative frequency. Okay, so this in here we calculated the column relative frequency, so we will compare the columns. Here we are calculating the row relative frequency, so we would be comparing the rows. Okay, sorry, I got messed up. This is the column relative frequency and this is the row relative frequency. See, here we are dividing it by the, just 1 second, just a second. No, it's correct. This is row relative and this is the column. Okay, so here see, we are calculating the 76%. It is 76 divided by 100, right? So we are calculating, we are dividing it by the row total, correct?
Yes, ma'am. Yes, ma'am. We are
Yeah. So
dividing.
this is row relative frequency and this is column relative frequency.
Okay.
Okay. So if my row relative frequencies are same, so this row relative frequencies are same, we say that they are not associated. Here we see that the column relative frequencies are same.
So we are comparing the Y column and N column and RT column. So they are same.
Yeah, correct. So
So
it's
in
like,
that way, we are saying that, okay.
yeah,
So it's basically the last row of these of the table.
yeah. Um,
Here, ma'am, in the first, there is column related also and row related also because we
yeah,
have total of
this
rows
is
also and column also.
correct. So this
So
is
we
row
can
relative
compare both
and this
way.
is, yeah, in both way you can compare. Okay. Now you understood how to like observe if there is a difference or not, if
Yeah,
the relative
yes, ma'am.
frequency.
Ma'am, yeah, ma'am, just one thing. To
Hmm.
calculate the row related frequency, we have to compare the rows. Yes, ma'am. Like rows, like female and male, we have to
Hmm.
give ratio of rows, na? We like,
Yeah, correct. So if we see like it's 76, 24, 75, 25, 77, 22. So it's like bit same,
okay,
the proportions. Yeah. So it must be like it will be much more clear if we
okay,
draw
okay,
like,
okay.
graphically also. Okay. So let me take one more example in which they are associated. That means like there is a difference in the row relative frequency and the column relative frequency. Okay. So this is an example. Okay. So this is the income level. Okay. So we have different income, high, medium, low, and this is the column two. Okay. So this is a row relative frequency. Is it understandable? Everyone?
Yes, ma'am.
Yes,
Just
ma'am.
seeing it. Yes, ma'am.
Yeah. Okay. So
Actually, we are
these are my,
writing also, ma'am. We are actually writing also notes, and we are also listening to you. So sometimes the reply can be a little delayed. Sorry.
okay. So you're writing it. Okay. Okay. Fine.
Sometimes some important points. That's all.
Okay. Fine. So, okay. So now, yeah, see the table. So here I'm asking you whether they are associated or not. So can anyone tell me?
Associated.
They are associated. Correct. Why? How?
Because here is difference.
Yeah, there is a
90%,
difference. Correct.
59%, 35.
Yeah. See, the difference should be like 62. The proportion should be 62% and 38. Like this should be the proportion. Okay. So here I'm seeing that it is 90, 10, 60, 41, 36 and 64. So the proportion is like it's disproportionate, right?
So,
It's
ma'am,
not
basically, 80 upon 10 should be equal to 59 upon 40 in a way to make it non-associate.
correct. Yeah, the numbers like if the numbers what were like let's say it's like 63% or 60%, 62%. Okay, and this would be like 36%, 39%, 35%, somewhat like that. So it is like a bit same, correct? The
Ma'am,
proportion.
just yeah, ma'am. So basically, the 63 upon 36 should be equal to 60 upon 39 should be equal to 62 upon 35 to make it non-associate.
Yeah, correct. Like not mathematically that the calculation should not be
Yes,
done,
ma'am.
but
Yes, ma'am.
in
But in
overall.
general, like
In
approx
general.
kind of.
Correct. So I think everybody understood it right now, how to
Ma'am,
observe it. Yeah,
in row relative frequency table, we are supposed to like compare the columns.
the rows. We are comparing the rows.
Ma'am, could you just brief out how should we recognize it's a row related frequency or column related frequency? Like sometimes the rows are equal, but we have to compare the column wise, right?
When we
See,
divide by row, I think.
we divide. Yeah, we divided
When we
by row.
divide by row total.
Hmm. See, overall, just don't just think about it like that. If you calculate, first of all, just calculate the relative frequency. Okay, so it depends upon you whether you calculate the row relative frequency or a column relative frequency. Okay, so here I have calculated the row relative frequency. Okay, so in general, if you look at the proportions, okay, so just like in general way, I'm
You have
telling you,
calculated the column related frequency here, na?
this is the row relative.
Uh, okay.
I'm just this percent is like 90 divided like not 90, there's some number divided by the row total. Here I'm having the row total, right? Some value. So I'm just dividing this number, this cell divided by the row total. Then I'm getting the percentage value. Getting my point?
Ma'am, this is a Y, a 90, 59, 35, and 62. This is first column. Yes, ma'am.
90, 59, and this is first column, right? Correct.
Yes, ma'am. So when we when you did the percentage x upon 62 total in this column we are comparing, na? So it's a
It's not
column related
x upon
frequency.
62. No, no, no. It's not x upon 62. This is like, what's your doubt, basically?
Ma'am, I am saying it should be a column related because the total is of column, na? The Y column we have total and N column we have total. So when we are having a total, it should be a column related frequency. That's what I
Okay.
was.
So this, no, no. See, here this is 77.27. How I calculated this? So I had this number, right? It is 34 divided by 76. This is 34 divided by 76. So
Yes.
no, this is column. Okay. So if I had calculated it by 34 divided by 44, right? If I had converted this into a percentage form, I would be getting this number, this 77.27%.
Yes, ma'am.
Correct? Correct.
Yes.
So now you tell me whether this is a row relative or a column relative.
If we are
Ma'am,
comparing
row
through the
related.
total, basically that is row relative frequency, ma'am.
Yeah, correct. Now you understood, Kashi?
Yes, ma'am. When the total is we are comparing through the total of rows, then it is a row related, na, ma'am?
Correct.
Ye- Okay, okay. So when we are comparing the like the y upon the total of this 44, y upon 44 kind of.
Hmm. So we are calculating the row relative frequency actually.
When
Yes.
comparing row total, then row relative frequency. Comparing column total, then column relative frequency.
Okay, ma'am. Yes, ma'am.
Just don't go that deep. Just look at like in general. Like if you can see the difference, then they are associated. Like here, if you see there is no difference, right? So they are not. They are
Ma'am,
not associated.
if there is a column total and there is not a row total, then it's a column related, na?
Related.
Like yes, ma'am. That's what it is. Like in this one, in the last one, the total is of column, so it is column related only because there is no row total here.
No, no, I have not written the row total actually. Should I make the
Yes,
whole
ma'am.
table?
But yes, ma'am. But when we are comparing, so there is column total only. By it, we are doing it. So we are comparing
Yeah,
it through column total only, na? That's what I
yeah.
was
This
saying.
percentage we are comparing it.
Okay, ma'am.
Okay. Okay.
Okay, ma'am.
So this would be like much more clear if we like graphically represented. Okay, so we have like we can graphically like bar chart, we can make bar chart and we can make stack bar chart. Okay, so what is a bar chart?
When we compare in the forms of bars, different
Yeah,
range
correct.
and all.
So if I had this table, okay, the like this is my table. Okay, I'm right now I'm taking this table. Okay, so if I compare this table and I make a bar chart here, okay, so I'm having, so I'm making a stack bar chart. Okay, so how do you make a stack bar chart? So I'm having two categories, female and male, and the numbers are like, you say like it's 20, 40 and 60. Okay, so the number of females we have, the number of females are like 44, right? In total, and number of males we have are like 56, correct? This is the frequency. This is a normal bar chart, correct?
Ma'am, which frequency you
ma'am.
are comparing with? The left hand one?
No, I'm not comparing. I'm just making a bar chart, simple bar chart.
Okay, so you took the numbers from the above table, na?
Yeah, this is like 44 and 56. The number of females who are owning a smartphone and the number of males who are owning a smartphone. Okay.
Okay.
Now I'm just converting this into a stack bar chart. Okay. What is a stack bar chart? In this, like this bar only, I'm just dividing into two categories. Okay. So the thing is, if I want to say the number of females who are owning a smartphone. Okay. So the number of females who are owning a smartphone is like 77%, right? Yeah, 77%. Correct? Okay, so this is the number of females who are owning a smartphone, and this is the number of female who are not owning a smartphone. So this is like 77%, and this is like 22%, 23%. So I've divided this bar, okay, into two segments, which is owning a smartphone and not owning a smartphone. So this is actually a star bar chart. Getting my point? Similarly, in males, like in males, the percentage who are owning a smartphone is like 75%, correct? So this is basically 75%.
So ma'am,
And
the chart name is star bar chart.
stack bar chart.
Okay.
This is 75%. So this is a stack bar chart. Everybody getting my point? What is the stack bar chart? How I made it?
Yes, ma'am.
Yes, ma'am.
Everyone? Sure? If you have any doubts, you can ask. It's fine.
But basically, ma'am, that
Hmm.
in that case, it is 100% stack bar chart.
100%?
Stack bar chart.
Yeah, that's a different thing. Okay, so see, this is a simple stack bar chart. Okay, this is a standard one. Okay, and if I have to make 100%, in that I am not considering the count. See, in this figure, I'm considering the count of number of females, right? So there are 44 females and there are 56 males, right? So in this bar only, in this frequency only, I have divided the bar into two segments, correct? This is a standard one. Got it?
Okay, ma'am.
Right, ma'am.
Yeah, but in 100% stack bar chart, we don't consider the count. Okay, we are just dividing it into two segments. Okay, so like I'm having two categories, female and male. So the bars, the height of the bars would be same for both of the categories because we are not considering the count. Now in this only we are dividing it. Okay, so this is like 23% and this is 25%. Correct? They are not owning a smartphone. This is owning a smartphone. This is owning a smartphone and this is not. Okay. So if you see overall, is there any association between them? This is the, yeah, owning a smartphone and this is gender.
Ma'am, this chart is 100%. What did you say the term?
Yeah,
This is called?
100% stack bar chart.
And that was not 100% stack bar chart.
No. If you are considering the count, then it's a standard stack bar chart. If you are not considering the count, then it's a 100% stack bar chart.
I think it is not associated.
It is not associated. So if like, yeah, so if you see, observe the things, observe the chart, you see there is no difference. There is no much difference here, right? Correct?
Yes, ma'am.
Yes, ma'am.
Everybody got my point? Similarly, if I
Because
make
the
a
ratio is almost same, na ma'am. Because the ratio is of yes and
correct,
no is almost same.
correct. Now you're getting my point? Slowly?
Yes, ma'am. Yes, ma'am.
Fine. Now, if I make another one, okay, so I'm now considering the income levels. Okay, so I'm having three incomes, which is high, uh, high, medium, and low. Correct? Now, so I'm having 100% stack bar chart, right? So the bars would be same overall. Now I'm making it making two segments here. Okay, so the first one,
In the last graph, yes, yes, no, no, it's a 100% stack bar chart. So the male and female can be any. The total male and female can be like 100 and 200 respectively. Like male can be 100, female can be, because we don't consider the count.
yeah, you can say that. So, but basically you're making this graph according to this table only, right? So this percentage, the percentage would be coming out of that table only. The number of females and
Okay.
males. Yeah.
Okay.
Yeah. We are just here. The bars are of the same height because we are not actually considering the count of the female and male. That's why it is 100%.
Okay, but if we don't consider the total exact count, even the percentage won't be that matter, na ma'am, because the percentage coming out of the count. So how that would be feasible data, because it's coming from the count of female na and male, the total one. Because if we don't know how much female we have and we think and we say that 30% own the smartphone and we have 30% of male, so how can we compare in that if we don't know the exact count? Then it would be a kind of a disruption in the data, how we can conclude that
So
exactly that it is.
before making the table, before making the chart, you're having the table, right? This percentage that you're
Yes, ma'am.
calculating,
Yes, ma'am. Yes, ma'am.
for owning and not owning, these are
Yes,
all
ma'am.
calculated by that numbers only, right? You're
Okay.
having the total, having the column total, you are having the whole total and all, right? You are having the numbers. With that numbers only, you are drawing this graph, right? Getting my point? So basically, like you can also make like a standard one, or you can also make 100% stack bar chart. Here we are
Ma'am,
not
ma'am,
like
but we have, if we have the count, if we have the count, then also we can make a 100% stack bar chart.
you can make it. Here we are not considering the count of the female and male. That's it. To observe the difference between the both of the categories, we are just not considering the count. We are just observing the difference between them. That's it. The difference between the ratio of yes or no. That's it.
Okay, but ma'am, unless we don't know the count, how can we conclude from the data of 100% stack bar chart? Because we should know the count, na? Like the count should be,
I'm not
constant.
understand his problem. Could you just elaborate his problem?
Okay, ma'am, maybe from the next example we can tell us, we can go forward. It's fine.
Okay. So let's say, so I'm making in the next table this high, medium, and low income level. Okay. So this is the 10% of the people who are not owning a smartphone, and the rest of them are owning a smartphone. And in the medium level, we have uh, like in the median level, we have 40%, or you can say 41%, something here, somewhat here. This is the like, in general, uh, I'm just drawing it. Okay. I'm not, okay. Then for the low income, we have 64%. So it is somewhat like here. Okay. So this is the yes segment. So if you see, this is a 100% stack bar chart. Okay, so if you see general, like in general, if you are saying there is a difference, right?
Yes, ma'am. This is associated.
So this is associated. You're not audible.
Associated means
Sorry.
So, ma'am,
Hmm.
uh, the person is asking that the association is between the gender and the income, or gender or the
No,
person
no, no.
has.
This is owning a smartphone and the income. This is between the own. This table is owning a smartphone and the gender. This is the income. So we are comparing
Okay,
owning
okay,
a
okay.
smartphone with the gender
So,
and with the income. So if we see here, the gender, like it doesn't play any role with owning a smartphone. But if we see the income, it is playing a major role, right? So like basically, if we see the person who are having high income, like this percentage of people are owning a smartphone, like major of the people, right? In medium, like 41% and 60% are owning a smartphone. Here we see that the low income, majority of them are not owning, like 64% are not owning it, correct? So we see that there is a difference. Like if you see the chart only, observe it, you see there is a difference, right?
okay, ma'am. So there is an association between the income
Between
and owning a
owning a
smartphone.
smartphone. Correct.
So there is an association between X and Y axis in that
Hmm.
way.
Correct. Now everybody got it?
Yes, ma'am.
Sure. Is it fine till here?
Yes, ma'am.
Okay, so can we proceed now? So this was all about the categorical. If we're having two categorical variables, then what are the things that we can do? What are the steps? Anyone?
Then we can know which is associated, which is not associated by comparing.
Ma'am, if the ratio is same, there is no association. If ratio is different, there is an association.
Not the ratios, the row relative frequency and the
Yeah.
column relative frequency. Okay,
Yeah.
it's not ratio, it's the relative frequency. Okay,
Yeah. If it is same, there is no association. If they are almost same,
they are
there.
not. If they are different, then they are associated. Fine. Can we proceed further now?
Yes, ma'am. Just one thing, as you have said in 100% stack bar chart, we
Mhm.
don't consider the count. So, don't you think the conclusion that we are making would be a little incorrect because we don't know the exact count and then we are thinking of the percentage?
See, I'm just asking you, like, if you're making this chart, okay, this chart. So where are you getting this percentage value? Can you tell me that?
So, total only, ma'am.
From the total only, right?
Yes,
We are
ma'am.
calculating from the total number of the high income people, the total number of
Yes, ma'am.
medium, right? So
Yes,
from
ma'am.
that total only we are getting this percentage, right? And this percentage is just we are graphically representing it.
Okay.
Okay. So like if I'm getting the values from that total, like from the total only, then how is it incorrect?
But how we can say that in 100% stack bar chart, we don't consider the number? If we are already considering the number through percentage,
No, no, no. See, here we can see that the height of this bar and the height of this bar is different. Is it?
yes, yes, ma'am.
This is like 44, right? This is 44 and
Okay.
this is 56. So we are having a height difference between the bars, correct?
Okay.
But if you see here, is there any difference in the height?
No,
Yeah,
no,
that's the
no.
thing. Here we are not considering the count. Okay, we are not
Okay.
considering the frequency. We are just making a chart. We are just looking up into the overall, like the segments, you can say. Compare the segments, you can say that. without considering the, here we are not considering the count, that's it.
Okay, so we are making a count at like constant and then comparing the smartphones kind of. Okay.
Kind of, yeah. Now got?
Yes, ma'am. Kind of got it.
Everybody, can I proceed now?
Yes, ma'am.
Yes,
Fine.
ma'am.
Okay.
Yes, ma'am.
Now this was all about categorical variables when we have two categorical variables. Now we are having two numerical variables. Okay. So if we have to calculate the association between two numerical variables, the first thing is we can draw a scatter plot. Okay. By graphically, if we have to calculate the association. Okay. So can anybody tell me what is a scatter plot? How we draw it?
Is like dot.
Yeah. So basically, like we have two axes. We have an x-axis. We have a y-axis. What is x-axis? X-axis is, it displays the explanatory variable.
Yes, ma'am.
And y-axis,
Response variable.
the response variable, correct? Okay. Now if I'm having, so let's say I'm having a data, which is age and height. Fine. So I'm having ages like 1, 2, 3, 4, and 5. And my height are like 75. These are centimeters. Okay. 75, 85, 94, 101, and 108. Okay. So now tell me which is the explanatory variable and which is the response variable.
Age is the
Ma'am,
Ages are
explanatory.
explanatory and
Okay.
response are high.
Yeah, so these are basically, the age is basically the explanatory variables, right? So it would be in the x-axis 1, 2, 3, 4, and 5. And my
Remember
response variables are
how
the,
to say that? How to say that explanatory is age?
because it explains. See, see, why I'm having the heights, there are changes in the height, right? 75, 85, 94, 101, 108, right? So these are the explained by the ages. So if my age is getting increased, then my height is also getting increased. So my age is explaining the height factor. Okay.
Okay.
Getting my point?
Yes,
Okay.
yes.
Let's take another example only. Like if I'm having like houses, right? So like there are two columns, like one is size and one is the price. Okay, so I'm having different sizes of, like in square feet, I'm having different, like 0.8 or 1, 2, 3, something like that. And I'm having prices, like different prices, like 68, 10 lakh, 20 lakh, 30 lakh. So now tell me which is the explanatory and which is the response rate.
Ma'am, the size is actually explanatory and the price is response.
Response, right? So my size is actually explaining the prices, correct? That's
Yes,
why
ma'am.
this is an explanatory and this is the response variable. Now got the difference?
Yes, ma'am.
Correct. Okay, so now we were making the scatter plot. So this is the x-axis. It is basically the age, and my y-axis is basically the height. Okay, so now we are having two variables, right? This is my x variable and this is my y variable. So what are the points we are having, which is 1,75, right? Then 2,85. Then we are having 3,94. Then
So,
we are
ma'am,
having,
basically, we always put explanatory variable on the x-axis and response on the y. It is by default like that.
yeah, correct. Okay. So this is x, this is y, this is x, this is y, x, y, similarly like that. So my first is 1,75. So my point would be here, correct? Then we have 2,85. My point would be here, somewhat here. Then I'm having 3,94, like here. Then we have 4,101, something here, somewhat here, and 108 here. So this is my scatter plot. This is how you draw a scatter plot. Everybody got it? how to make it? How
Yes,
to make
ma'am.
a scatter plot?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. So now if I'm given a scatter plot, how will I visualize it? Okay. So, so there are four things by which we can describe the association through a scatter plot. Okay. So the first thing is by the direction. Okay. So what do you mean by the direction? If my like the pattern. Okay. So if I'm having a scatter plot, so this is my scatter plot. Okay. So what is the direction?
Up.
Up, right? So, so we are having like, we can have an upward direction, we can have a downward direction. Okay. So these or, oh, yeah. So we can have a linear, like there is no direction. There is like straight line. Okay. So through direction, we can like describe the association. Okay. So like if it's upward direction, that means like if my X variable is increasing, then my Y variable is also increasing. Correct?
Yes, ma'am.
Yes, ma'am.
Correct. If I'm having a downward direction like this, let's say, okay, this is a downward direction.
Yes, ma'am.
Yeah. So this is telling me that if my X variable is increasing, then my Y variable is decreasing. Correct. So through direction, we can measure this, like we can describe the association.
Yes, ma'am. We can say that the slope is negative in the
Yeah.
downwards.
Okay. So this is my first thing. Then the second thing is curvature. Okay. So we can have like, we can have linear or we can have curve.
Curve.
Okay. So if you see here, this is like a linear, correct? Linear upward and this is linear downward, right?
Yes, ma'am.
What do you mean by the curvature? Like if I'm having a, okay, let's say, so if you see here, like there is a little curvature here, correct? It's increasing, it's upward direction, but it is not linear. It's a little curve. You getting my point?
Yeah.
Yeah. So this is a curve. Like there is a curvature here. Okay. So there are two types of curvature. Either we would be having a linear or we would be having a curve. Got it? But like for your sessions, we would be considering only the linear curvature. Fine.
Ma'am, in the next session, in the upcoming session, we'll be having curvature also.
We would be having?
Curvature also.
No, no,
Like,
no.
okay.
No, we will only consider the linear one. Okay.
Okay, ma'am.
Yeah. So now you understood. We have direction, upward, downward. Then we have curvature, which is linear or curve. Then we have variation. Okay. So what do you mean by variation? Whether the like the whether it is tightly clustered or it is or not. Okay. So if I'm having like if you see this figure, now tell me whether there is a variation or not, like whether it is tightly clustered or not.
Tightly clustered, I think.
It is tightly clustered, right? Everyone?
Yes,
Ma'am,
ma'am.
which
Yes,
one?
ma'am. Yes,
This
ma'am.
is tightly clustered. Okay.
Yes,
Now if
ma'am.
I'm having, okay, now if I'm having this figure, now tell me,
No.
is it variable or tightly clustered?
Ma'am, it's a kind of variable.
Yeah, it's a variable because it is not, the values are not like same. They are variable. There is a variation. right? So this way you can tell whether there is a variation or not, whether it is a tightly clustered or there is a variable in it. Fine. Now the last one is outliers. Okay, so what do you mean by outliers? If I'm having this figure, then I'm in some points like here, right? Somewhat, some points are like out of the like it's very different from the other values. Then we say that these are outliers. Okay, so there are four things. Okay, so to describe an association through a scatter plot, the first thing is the direction. We can have the upward direction, we can have downward direction. Then the second thing is we would be having curvature, whether it's linear or curve. Then the third is variation, whether it is tightly clustered or variable. And the last one is outliers, which are very different from the other values. Okay, exceptional ones.
In the last slide, when you just go a little up. Okay, ma'am. Okay, got it. Got it. Just take a screenshot, just like that for the.
Okay.
Okay, a little up, ma'am.
Now, can we get this slide?
Sorry? Could you repeat? I couldn't get you. Pradeep?
Can we get this slide, this presentation?
This, yeah, we will share it for sure. The supplementary contents after I think after 2 or 3 days, like after this whole session, after Hindi sessions and the doubt sessions, I will be uploading it. Fine?
Okay.
Yeah. So till here, is it clear? The scatter plot and how to describe it. Is it fine to everyone?
Yes, ma'am.
Sure. Can we move forward now?
Yes, ma'am.
Okay, so we have graphically represented the association between two numerical variables through a scatter plot. Now we will measure the association numerically. Okay, so there are two ways we can measure it. The first one is, anyone?
Covariance.
Covariance. Correct. So can you tell me what is covariance?
It qualifies the strength of the linear association between numerical variables.
Numerical variables. Correct. You know what is the formula of a covariance?
Sorry, it is mean minus deviation into like two variables.
Okay.
Sum of
Sum of x minus x bar into
X
y
bar.
minus y bar.
Yes, ma'am. X bar
I
is the
equal to I equal to 0 to n.
Okay.
Yeah, it can be from 0 to n something. Okay, so the divided by
n or n minus 1.
Okay, so
N
we can
is
have
for population and n minus 1 is for
so
sample.
we have so we are having two types of covariances. The first one is we are having a population covariance in which we divide it by n, and we have a sample covariance, okay, in which we divide it by n minus 1. Okay.
Here we
So
are multiplying x1 minus x dash into y1 minus y dash.
Ma'am, what is covariance?
Covariance is basically, it tells you the strength between, it tells you the direction of the linear association between two variables. Okay, so let's say, okay, I'm giving you an example here. Okay, this is age. Let's calculate. Okay, so this is price. So this is my x variable, this is my y variables. Now my age is like 1, 2, 3, 4, 5. Price is 6, 5, 4, 3, 2. Okay, now I have to calculate the covariance between them. Okay, so this is basically the age of a car and a price of a car. Okay, so we are comparing the age and price of a car. Okay, so if it has been like 1 year, it can be of 6 lakhs or something. Okay, so this is about cars. Fine. Now, I have to calculate the covariance. Okay, so for the covariance, the first thing is I have to calculate xi minus x bar, right? So what is x bar here?
Mean of age.
Mean.
It's the mean, correct? So I have to calculate the mean of x variable. So it would be the mean of x variable would be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. Correct?
Yes, ma'am.
Yeah. So my mean would be 3.
Yes, ma'am.
Right? Okay. Now, so xi minus x bar, that means xi means the values. This is x1, this is x2, this is x3, this is x4, and this is x5, right? Getting my point?
Yes, ma'am.
Yes.
Yes, ma'am.
So I would be subtracting x1 minus, I would be subtracting x1 from by the mean. Okay, so it would be 1 minus 3, correct?
-2.
So this would be minus 2. Then I'm having minus 1, 0, 1, and 2, correct?
Yes, ma'am.
Okay. Similarly, I would be calculating yi minus y bar. So what is y bar? It is the mean of the y variable. So this would
Mean
be,
of price.
yeah, so this would be 6 plus 5 plus 4 plus 3 plus 2 divided by 5, which would be equal to 4.
4.
Correct? So now this value would be, anyone?
2.
2,
1.
1,
0.
mm,
-1.
mm,
-2.
minus.
-2.
Ma'am, we
Minus
can also do na like x bar minus
minus
x1 and y bar minus y1, or we have to do only x1 minus x.
Sorry, what?
Ma'am, can we do x bar minus x1 also and y bar minus y1 also, or x1 minus x bar only we have to do?
No, we have to do only x1 minus x1.
Okay, okay. It's
Yeah.
by default, like, okay.
Yeah. Okay. Now we have to multiply these two columns. Okay. So this would be xi minus x bar into yi minus y bar. So this would be minus 4, minus 1, 0, minus 1, and minus 4. Correct? Till here, is it fine?
Yes, ma'am.
ma'am.
Everyone?
Yes, ma'am.
Yes,
Correct?
ma'am. But after that, what we have to do?
Yeah, after that. So if I'm calculating population covariance, okay, population covariance I'm calculating, it is summation of xi minus x bar, yi minus y bar divided by n, correct? Is this the formula? Everyone?
Yes, ma'am.
Yes,
Right?
ma'am.
So what is my summation of the product, right? So this, I would be calculating this sum.
-10.
It would be minus 10. Okay, this is my summation of xi minus x bar, yi minus y bar. This is minus 10
Ma'am,
divided by,
is it, ma'am, in the table when we added it, just if we can go in the table, -4, -1, okay. So it's -10, okay. I was just calculating it, ma'am, and taking a screenshot of. Okay, ma'am.
yeah. So then dividing it by the total number of observation, it is 5.
Yes, ma'am.
Yeah. So it is minus 10 by 5, which is equals to minus 2. Is it clear till here?
Yes, ma'am. Clear.
Okay. So I'm getting my value as negative, right? That means my covariance is negative. So like my direction is going negative. That means if my x variable is increasing, if you see the table here, if my x variable is like increasing, my value of y is also decreasing. It's going into
Yeah.
opposite direction.
Yeah.
Yeah. So that way we can observe the direction of the linear association between two variables. So for that we calculate the covariance. Okay. Understood?
Yes, ma'am. Yes.
Okay.
So, ma'am, you said we calculate the covariance to find the relationship between x and y.
Correct. Okay. If I have to calculate the sample covariance, then it would be minus 10 divided by what?
4.
It should be 4.
It would be 4. So this would be something minus 2.5.
Minus 2.5.
Yeah. So this is the thing.
Ma'am.
We are having the covariance in negative. That means it is going downwards. So if my
Yeah,
x is
downwards.
increasing, my value of y will be decreasing. They are in opposite direction. Everybody got it?
Yes,
Yes.
ma'am.
Yes, ma'am.
Now, if we have the covariance, then why we calculate the correlation?
Because drawback is unit.
Unit, correct. So my x is like in years, right? This is my in years and this is like in lakhs. So I'm having two units, years into lakhs. This is not quite representable, or it is not okay to have a value which is having two units, right? Years and lakhs. So we have other quantity which is unitless. So that is the correlation. So my next thing is correlation, which is a unitless value. Okay.
Yes, ma'am.
Everyone?
Yes,
So
ma'am.
use
Yeah. So,
correlation because there is some kind of a issue in there's unit in the
yeah,
unit.
correct.
Okay.
See, if I calculate the population covariance, I would be having the result would be in units only, right? Years into lakhs. So it would be minus 2
Okay.
years into lakhs. Correct? Is it representable? Like, have you ever seen a unit which is having this type of values which is having this type of units? No, right? Correct? So
Yes,
that's
ma'am.
why,
Yes, ma'am.
yeah. So that's why we calculate another value which is unitless. Okay. So for that we calculate the correlation, and the correlation is represented by R, and the formula is covariance of x comma y divided by the standard deviation of x variable and standard deviation of y variable. Okay, so correlation basically tells you the strength and the direction of the linear association between two variables. Okay, so it will tell you the number, the values, and also the direction, whether it's negative or it's positive. Okay, so the correlation is represented by R. The formula is covariance of xy divided by the standard deviation of x into standard deviation of y. You can also write it as summation of xi minus x bar yi minus y bar divided by under root of summation of xi minus x bar square summation of yi minus y bar whole square. Okay. So if you see here, my x variable was in years, correct? This was in years and this was in lakh. Okay. Now this is summation of xi. This is whole square, right? This would be years square. If we take the square root, it would be years only, and this would be lakhs only. So if you see, the units are getting cancelled. So this is basically a unitless value. That's why correlation is preferred more.
Ma'am, a small confusion. Ma'am, for standard deviation and correlation, the denominator is n and which is getting cancelled. Am I right?
Yeah.
That's why you're including n. divide by n or n minus 1.
Yeah.
Okay, thank you.
Okay. So this is my formula of correlation. Okay. So if I have to calculate, okay. Now my value of correlation, okay. So let's calculate the correlation from this value. So basically this was my table. So my correlation is summation of xi minus, so, okay. So my R would be, that is summation of xi minus x bar, yi minus y bar, right? So this would be minus 10. This is minus 10,
Yes, ma'am.
correct? So this is minus 10 divided by, now summation of xi minus x bar whole square root. So basically this value, the square of this value, right? Xi minus x bar whole square, right? So my values would be 4, 1, 0, 1, and 2, correct? So my, sorry, 4. So my sum would be 10 only. This is my square, actually. The square values. Just don't get confused. I didn't make the other column. I'm just calculating here only. Is it fine to everyone?
Yes, ma'am.
Okay. So this is my summation of xi minus x bar whole square. So this value, summation of xi minus x bar whole square is 10, right? So it would be square root of 10. Is it fine?
Yes, ma'am.
Everyone? Kash.
Ma'am, came, ma'am?
Yeah.
Yes, yes, ma'am.
Clear?
Ma'am,
Hmm.
ma'am, how under root 10 came? We
See, it's summation of xi minus x bar whole square, correct?
okay.
Right? So I calculated the square of this value, xi minus x bar. It was minus 2, square of minus 2 is 4.
Okay. So it's
Yeah.
minus 10. And
So
when we make it square, so it will become.
yeah. Okay.
Okay, we'll go to the last slide once.
Is it fine till here?
Yes.
Similarly, I can calculate.
What was his doubt? Like, I couldn't catch.
Like he's asking about how we got this square root 10.
So basically, it was minus 10. The minus 10 square was 100. So 100 root was 10.
No. Okay, let me take. Like, see, just forget about this. We are calculating this value. Okay, just focus right here. Just don't write now. Okay, just focus right here. Okay, just don't write anything on your notes. Okay, just focus here. So we are first calculating summation of yi minus y bar whole square. Okay.
Yes, ma'am.
Yes, ma'am.
So my yi minus y bar, the values of yi minus y bar are this. These are the values.
Yes, ma'am.
So the whole square would be 2 square is 4, 1 square is 1, 0, minus 1 square is 1, and 2 square is 4. Correct?
Yes, ma'am.
So my sum would be 10.
Yes.
Correct? So here it is some square root of summation of yi minus y bar. So this value is like somewhat 10. So it would be under root of 10.
Yes.
Right? So
Okay,
if, yeah, now you got it. So the value would be minus 1.
yes, ma'am.
Yeah. So this is how I calculated the correlation. Everybody got it?
Could you go to the previous page once?
This one?
Yes, 1 second.
Yeah. This is my square of x variables. Okay. I didn't make the.
No problem. Yeah.
Yeah.
Both are 10 only. Yeah. Now I got it.
Both are 10.
Okay. Yeah. Done, ma'am.
Done. Everybody?
Yes, ma'am.
Yes, ma'am.
Is it clear how you calculated the correlation?
Yes, ma'am.
Okay. Now tell me, now what is the range of correlation?
-1 to 1.
-1 to 1. So if we are, so here we can see the correlation is -1. That means it is strongly negative.
Yes.
Correct. If I'm
Ma'am, it
having,
should be equal to, there has to be an equal to sign also, na? I guess, between -1 and 1. Like,
yeah. Okay. So yeah. So this is strongly negative. If I'm having some values like 0.98 something. So now tell me about this. If my R value is 0.98, what can you say about it?
ma'am, it is increasing, but not strongly increasing.
Why?
Maybe it is increasing, I guess. It is increasing, strongly increasing.
It is strongly positive.
Yes, ma'am.
Correct. So if my value of R, that is the correlation, is near to 1, this is basically 1. Like if you round off it, it's basically 1 only, right? So it's near to 1.
Yes, ma'am.
Correct? So if my value is near to 1, we say it's strongly positive. If it's near to -1, we say it's strongly negative. Got my point? If it's 0, then there is no correlation. Is it fine till here?
Ma'am, if it is 0, it's variable. It's not tightly. We can say that it's not tightly clustered. Can we say that in variations it is variable?
They are not associated, I guess, ma'am, if it's 0.
Yeah, they're not associated.
Okay, okay.
There is no association between them.
Ma'am, for exact 0, we should tell that, right?
Yeah, correct.
If it is a bit like 0.1 also, we should tell
Then
they are
yeah, then
weakly
it's like
associated.
negligible only, right? It's like 0 point, like it's if it's 0.1 only, that means it's 0 only.
Yes. No, no. I was just, wanted to ask, can we say it is weakly associated or totally 0, not associated?
Basically, that is no relationship when it is 0.
No, I wanted to ask if it is closer to 0, should we say weakly associated or not associated? My doubt is that.
If it's point. Yeah, you can say that it's weakly. You can say it right, like that. But if it's like 0.1, 0.2, then I think you can say it's like there is no correlation between them. But if it's like you can say 0.5 or 0.56 or 0.6, then you can say that it's weakly correlated.
Ma'am, actually, based on lecture, when ma'am, we have got for 0.5%, we should tell it as moderate.
Moderate, yeah.
Yeah. I was confused for weekly and zeros, so no problem. Yeah. It's more sort of commonsensical, I guess.
Yeah, you can say that. But basically, like you will get simple values. Like it will be easy on you. Okay. So
Yes,
now it's
please
clear.
continue. Yes, ma'am.
Sorry.
Continue, ma'am.
Yeah. So now it's clear to everyone what like how we calculate the correlation. What is the correlation? What is the difference? So okay, can you tell me what is the difference between the covariance and the correlation?
Correlation has no units, covariance has units. And
Correct.
it's easier to interpret from correlation, the strength of the association of linear association.
Good.
It
Good.
becomes easier.
Yeah. Correct. So
And also, I
everybody.
think covariance doesn't have any limits, but correlation is only between -1 and 1.
One. Good. So I think everybody is clear with the topic, the correlation and the covariance, right?
Yeah.
Okay. Now, okay. Now the last second topic is like R square. Okay. So if I have to describe the linear association using a equation of line, okay, then I would be like if I'm having let's say if I'm having a scatter plot, like this, right? So if I have to describe this linear association through an equation of line, so I would be making one line, right? Okay, and I have to describe this through an equation, right? So the equation of this line would be somewhat like in the form of y is equals to mx plus c, correct?
Yes, ma'am.
Right? So where my y is? Anyone?
Y-axis points.
Response variable.
Response variable. Then what is m?
Slope.
It's slope. What is x?
Explanatory variable.
Explanatory variable.
Yeah. And c is?
Intercept.
Intercept.
Intercept. Correct. So basically, I can describe a linear association through an equation of line. Okay. So this is like, let's say this is my, this example only. This was age. And these are the prices of car, correct? So if I describe this through an equation of line, so it is somewhat like y is equals to minus 0.694 into x plus 9.03. So this is the equation. This is how I represent through an equation of line. Okay, so this is my response variable, this is my explanatory, and this is my slope. And just don't go according to this graph. Okay, so this is my intercept value. So if you see here, okay, so my this is my slope, right? So it is minus 0.694. So this is basically going downwards.
Yes, ma'am.
Yes, ma'am.
So yeah, so I can say that with the increasing age, we can say the prices are going down. So
Yes.
I can like through the line also I can associate, right? Then we can also calculate the value of R square. R square is basically the
How
goodness
did
of
you calculate minus 0.694 and 9.03?
like you don't have to calculate that. It's like it's out of your syllabus. Like if you go through like from the Excel sheet, you you will have these values. So I'm just telling you, you don't have to calculate. There is no
Okay. You just wrote a random equation. Okay.
Yeah, correct.
And the prices are increasing, right? Like it is not the graph that is showing up.
No.
Yes, ma'am,
I
because
just
the slope.
with the graph. Okay,
Don't see the graph.
Yeah, just don't see the graph. This graph is some other
Okay.
thing. It's just general. So this is a different thing. Okay. So if I'm having an equation, okay, y is equals to minus 0.694 into x. If I represent, okay, let me just. So this is my graph. Okay. So I'm having a line here, and this line is represented by this equation. So if you see here, my slope is going downwards, right? So that is, it is negatively associated, correct? So through equation of line also, I can describe an association between two variables, correct?
Yes.
Yes.
Getting my
Yes,
point?
ma'am.
Yeah.
Yeah.
Now I can calculate R square also. What is R square? R square is basically the goodness of fit. Like how good fit is the line here. Okay. Like if it's showing any variable, like the points are really close to this line, right? So this is a very good fit. Right? You're understanding? So if I calculate the R square value, it is getting to be 0.855. Okay. And my correlation was it was basically minus 0.9247. Okay. So if you see here, R square, my value is 0.85. Basically, it is near to 1. Uh, the range of R square is between 0 to 1. Okay. And the range of R is from minus 1 to 1.
Yes,
Ma'am,
ma'am.
here the R square value should have equal to sign also in the like just asking. I don't know.
No.
Equal to sign also. It can be 1 or 0 also.
I'm not sure. Let me. Just a second, let me
It
check.
can be equal to 1 because there are values where mu or r small r is equal to 1, so we can r square could also be equal to 1, right?
Correct. Yeah. So basically, this R square is the square
Ma'am, but
of this correlation. Okay. So if I'm
okay,
having,
okay.
yeah. So R is like it is minus 0.9247. So if I square this value, I would be getting 0.855. Okay. Basically, the range of R is going from -1 to 1, and the value of R square is going from 0 to 1. Okay.
So ma'am,
Yeah.
can't we write big R square like as small r square if it is so?
No, no, no. This is the
Because it
representation
is the
of,
square, ma'am. It is the square, na? This can be termed as big R, but can't it be write it small r square?
no, no. It's the, this is the representation of R square. Means, yeah. This is the correct representation, and this is the representation of a correlation. This is the goodness of fit line. This is correlation. These are two different terms. Okay. Is it fine?
Yes, ma'am.
So, ma'am, you are saying this big R square is the goodness of fit line and small r is the
Correlation.
correlation. And you are
Correct.
saying the goodness of fit line, if it is more closer to 1, it is a good fit line.
Good fit. Yeah.
And if it is between 0 to 0.5, it is not a good fit line.
Yeah. If it is near to 0, then it's not a good fit line.
Okay.
Yeah. That's it. Okay. Now can we move forward to the last topic? Everyone?
Yes, ma'am.
Yes, ma'am.
Yeah.
Okay. Now the last topic is, till here we calculated the association between two categorical and two numerical. Now, if you're having one categorical and one numerical, then how would we calculate it? Through point-biserial correlation coefficient. Okay. And this is denoted by RPB, and the formula is x bar naught, x bar 1 bar standard deviation of x under root of p naught p1. Okay. So, okay, let's go through an example. Fine. So if I'm having one column, which is uh, the students passing, okay, if they are passing or not, passing the exam or not, and the number of hours they are studying. Okay, so I'm having values like 1, 1, 1, 0, 0. 1 means that they are pass, and 0 means they are getting failed. Okay, and the number of hours like 8, 7, 9, 4, 3, and 5. So now tell me which is a categorical and which is a numerical variable.
Sir, ma'am, pass is a categorical, ours is a numerical.
Yeah, correct. So we are now calculating the association between the categorical and the numerical variable. Okay. So through R, that is point-biserial, it is x bar naught minus x bar 1 divided by the standard deviation of x under root of p naught and p1. Okay. Now what is x bar naught? Here my x bar naught is, you can say,
Mean of set 1.
yeah, you can say that, like the number of people who are fail, like my 0 representing the fail, right? Okay, so x bar 0 is considering the one set of variable, one set of value, So I'm considering as fail. Okay, so this is the mean of the number of students who are getting fail. So this is 4, 3, and 5. So I would be calculating this mean, correct?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
So I would be getting x bar naught as 4. Similarly, my x bar 1 would be what values? The mean of
Pass value
pass, yeah.
879.
7, 9 divided by 3. So this would be basically 8,
8.
correct? Now I have to calculate standard deviation of x. That means I'm calculating the standard deviation of the numerical variable, this value. Okay, so if I calculate the standard deviation, I am getting as, let's say, 2.16, something sort of. Everyone can calculate the standard deviation, right?
Ma'am, we have to take the under root of the x square that, huh? Yeah.
Yeah, the formula, that summation of xi minus x bar whole square divided by n, the whole square root.
Yes, ma'am. Yes, ma'am.
Okay, so through that we can calculate the standard deviation. Now, what is P naught and P1? P naught is the proportion of students who are fail. So there are 3 students, correct? Out of 6, there are 3 students who are fail. So it is 1 by 2.
Half.
Similarly, what is my P1? Anyone?
Number of
3 by
student
6.
passed proportion.
Yeah, so it would be,
6.
sorry,
3 by 6.
3 by 6.
3 by 6. So this is 1 by 2. So we have calculated all the values. We have got P
Ma'am,
naught.
how did we calculate P naught? It's number of the student who failed upon the total number, and P1 is the
Yeah,
number of total who passed upon the total number.
correct, correct. Okay, so now putting all these value here, we would be getting the value, the point-biserial correlation coefficient. Everybody got it?
Yes, ma'am.
Yes, ma'am.
I don't have to put the value, right? Like it's just a general example. So you got to know how to calculate it, right? Just first, differentiate the values which are like for what are zeros and what are one, right? Then calculate the mean for each of the categories. Then calculate the standard deviation, calculate the proportion, and put all these values in this formula. Got it?
Yes,
Ma'am,
ma'am.
Yes, ma'am.
delta x is the standard deviation, na?
Delta x, it is not delta, it is S only.
Okay, Sx. Okay, okay, okay. It looks like that. Okay.
Now you got it?
Yes, ma'am.
Yeah. So this was the last topic. So till here, anybody having any doubts in this topic, in this
Ma'am,
week?
there is a question from activity questions. I'm not like there is a theory called Simpson's paradox, it seems. Do you know if possible, could you explain what is that?
Which one, which activity can you tell me?
Yeah, 2 minutes, ma'am. I also don't remember. I have to just check it.
Yeah, okay. No, there is a doubt session, so I can clear the doubts there only if you want. You have another session, right?
It's not an activity question. It's some concept yeah, it's given over there. I couldn't understand that. I just want to explain you to explain the concept, not the question.
Okay, okay.
What was the topic that you said? Which paradox?
Simpson's paradox, I guess. I'm not sure. I just wrote it somewhere. I have to read it again. Is the correct meaning of that word?
Uh, see, basically, it's you can say that. See, like if you see the question only, uh, if you can tell me the question, then it would be easy for me to make you understand.
1 minute, ma'am.
Okay, other than this, anybody having any other doubts? Anyone? No doubts? It was clear? Was it clear to everyone?
Yes, ma'am.
Yes, ma'am, it was clear. Thank you so much, ma'am, for teaching.
Okay, so that's a good thing. Nobody's
And
having any.
practice assignment 2, question number 4. Near question number 4, it's given. Yeah, it's Simpson's paradox.
Wait a minute. Practice number? Practice assignment?
4.2.
Question?
It's given on cricket. I just want you to explain the question, not the like. It's given over there. Could you just?
Right. Okay. See here. Okay, so if you like, if you look into the table only, you have opened the table, right? You have the question right in front
Yes,
of
ma'am.
you.
Yes,
Okay.
ma'am.
So you have a table of like we have captain A, captain B. We have different rows. Then we have total matches, home and away. Then we have home and away, like 3, right? So basically, Simpson paradox. It is a like the like there is a different trend when we calculate like um, home means from the data. Let me check against the record. Have you seen the solution?
No, ma'am. I couldn't understand, so I just skipped that question. 8th question is related to that.
Yeah. So
I thought of asking you first. Okay.
yeah, it's fine. So can you open the solution of that? So it will be much more clear. Okay, let me share the screen then. Is it visible?
Yes, ma'am.
This is the question, right? Okay. Now we have in this table we have calculated the win percentage of captain A, captain B. For whom it is 90%. For away, this table is clear,
Yes, ma'am.
right? And this is a draw percentage. This is the loss percentage. So these are the three tables that we have drawn. Okay. Now the Simpson paradox, it is actually like so if you see here, this is the winning percent. So if you observe who like which like for which captain the winning percentage is higher, like from here, this one. It is like somewhat like you can say captain A, right? Like it's 90 and 53,
Yes, ma'am.
right? But in total, captain A, right? But in total, if you see that the captain A, the winning percentage of captain A is less than captain B, correct?
Yes.
Right? So this is a Simpson paradox. So if we see differently, we see that the observation is different. But if we take it as a group, right? So home is a different group, away is a different group, right? So if we calculate the total of home and away, we see that captain A is the winning percentage of captain A is less than captain B. But if we see individually, we see that captain A, the winning percentage of captain A is much more than captain B. You getting my point?
Yes, ma'am. Now I get it.
Yeah.
If the row total is like it's changing, but if we take as a column, like individually, if we check out captain
Yeah.
is performing
Correct.
better. Okay, yeah.
Individually, it's different, but if we take the total, it's different.
Yes, ma'am.
Yeah.
Okay.
This
Yeah.
is the Simpson paradox. Got it?
Yes, ma'am. I understood now. Yeah. Okay. Thank you.
Yeah. So anybody else?
No, ma'am. Thank you so much. We can
Yeah.
end
So,
recording, I guess.
yeah. Okay. So tomorrow we are having Hindi sessions. So today only 15 of you joined, right? You don't get any reminders or something, or nobody
I
like.
guess people don't wanted to join. Yes.
Okay, then it's fine.
Ma'am, it's not only in your class, in the maths class also, very less people join, and in other session also, because there are students who are not doing it as stand alone, so they have some classes or some kind of jobs, so they see the recording sometimes.
Okay, then it's fine.
Thank you so
And
much.
I guess it's Sunday also
Ma'am,
today, so maybe for that reason, I guess.
Yeah, maybe. Okay, then
ma'am,
fine.
you are saying that you can find this PDF in supplementary content, but I'm not able to find there.
No, this I am not uploaded yet. So after like completing my week 4 sessions,
No,
right? The weekly, and
previous PDF also, week 1, week
it's
2,
not
week 3.
uploaded.
Yeah, not uploaded, ma'am.
Let me see. I have not seen it yet. Just a second. If it's not uploaded, then just give me 2 days, then I will get it uploaded. Okay?
Okay, ma'am.
Yeah. Okay then.
Ma'am,
Yeah.
ma'am, I have some questions from graded assignment 3. When I can ask that?
Graded assignment. So
Yes,
you are
ma'am.
having math sessions now at 8 o'clock.
No, ma'am.
You're not having? Yeah,
No,
Yes,
then
ma'am.
ma'am.
it's
Ma'am, actually, I'm not attending.
okay. Okay, it's fine. Yeah, then I'll clear your doubt then. It's fine.
Okay.
Okay, so yeah. So anybody like no one is having any doubts, right? Everything is clear?
Yes, ma'am.
Okay then. So have a great day now.
Thank you.
Enjoy your Sunday. Bye everyone.
Thank you, ma'am.
Yeah. You can leave. Okay, so Neetu, right? You
Yes, ma'am.
yeah,
Ma'am,
so
tomorrow you will be taking the class of the Hindi session.
yeah, yes.
Okay,
So,
ma'am. Okay.
same thing you will teach in Hindi also.
Yeah, same thing I will be teaching in Hindi.
So, I think no need
Okay.
to attend because I attend English session.
Sorry?
So, you will teach same thing, so no need to attend, I think, because
That
I
depends
attend
upon you.
this.
That depends upon you. Like there are many students who like they are more comfortable in Hindi, so they attend that.
Okay. So, ma'am, all the Hindi session of statistics, if we attend the English one, there is no need to do that, na, ma'am.
Yeah,
Because
it's
because
up to
you only
you.
take the Hindi session, because if there is some other
Correct.
faculty, then there could be some other
Difference. Yeah.
topics. Ma'am, there could be difference. Oh, ma'am, you only take English and Hindi, so in all the session upcoming also till the qualifying, we can only attend one session, Hindi or English, na? That's what I was asking.
Yeah. Okay then. Yeah, so okay, Neetu, you were what was
Ma'am,
it about?
ma'am, question number 3 and question number 10 from graded assignment 3.
Graded assignment 3, question number.
Question number 3 and question number 10.
Okay. So have you watched Solve with Us of week 3?
No, ma'am. No, ma'am.
No? So first you go and see the Solve with Us. Okay. Same question is there and it is solved. So just Go through that, and even then, if you're having a doubt, then I'll clear it. Fine? For the third question, I'm telling.
Ma'am,
Okay, Nico?
if we
Ma'am,
have
for 10th question last.
Okay, for the 10th question, what is the interquartile range? So you have to calculate quartiles right now. Quartile 1, quartile
Ma'am, the last part, it is said, I think it extends till 20 points. I'm not able to understand that only.
What you're not understanding? It's a leaf plot, right?
Yes, ma'am.
Yeah, so what you're not understanding here?
Ma'am, in the last part of the question, it is given it extends till 20 points, something like this. It is given.
Extends to 20 points. Okay, the question is different. Just a leaf plot. What is the median rating? 3 points available. All of his ratings are converted to 10 points. I think it is just a second.
Ma'am, if we have some future doubts, do you have like some email or something through which we can clear?
Yeah, we have discourse platform, and then we have mail. Like my mail is not in the discourse or something.
Okay, so if someone wants to ask that out, like
You can mail me also, like it's Swati.
yeah, ma'am, can you share your mail ID? It's Swati dot.
Swati S @ I'm just study.
What's the spelling, ma'am? It's
Just
SWATSY.
messaging you, mother.
Okay.
Texting. Yeah. Something else. Yes. Yeah, this is my mail. You can.
Ma'am, aren't you on LinkedIn or something if somebody wants to connect for internship or something?
Yeah, for internships.
Are you on LinkedIn or something?
Yeah, I'm on LinkedIn, but not that.
By what name, ma'am?
Swati only.
Like, how can I find like surname or something?
There is no surname. Swati, like you can find.
Ma'am, we have to send the solution for week assignment, graded assignment 5.
5.
Yes,
The
ma'am.
solution.
Ma'am, we have to send the solution for graded assignment 5 also.
You don't have to send any solution. You have just to like submit the assignment, right? The options you have to.
Yes,
Okay,
ma'am.
Neetu is here, right?
Yes, ma'am.
Yeah, so the question was like you have to convert into 10 points, right? So you have to basically like like multiply all the observation by you can say 10 by 100. So I have to explain it, right? So would you be attending tomorrow's session?
No, ma'am.
Day after tomorrow, doubt session?
Ma'am, I have to see the schedule.
Yeah, for like for the first few minutes, if you want. Then I'll clear your doubt.
Yes, ma'am, I can.
Yeah. Okay. Then day after tomorrow, I will clear your doubt. Fine.
Ma'am, what will be the time for that?
I think it's 6 to 8 only, right? So
Okay, ma'am.
anytime, like between 6 to 8, if you're
Okay, ma'am.
free, join. Okay.
Yes,
Yeah.
ma'am. Thank you, ma'am.
Okay then. So yeah. So anything else? Anyone? Can we close the meeting now?
Yes, ma'am, we can.
Okay. So if you have any issues and all, everybody got like you got my mails, right?
Yes, ma'am.
Okay then. Okay then. Bye. Good night.
Thank you.
Thank you, ma'am. Thanks for teaching.